In this video, I want to show how I used AI skills, agent swarms, Codex and Cursor to move my Unity game called Run the Strait from a prototype towards an actual App Store launch pipeline. I already covered agent swarms in my previous video. So in this one, I am going to focus mostly on the AI skills, the reusable rules and standards that made the agents useful in the first place. The most important thing I built for this game was not the weapon system. It was not the shaders. It was not even the build scripts. It was the AI production pipeline around the game. A prompt is a one-time request. A skill is a permanent job description for the AI. Instead of asking AI to help with one feature, I started giving them repeatable production rules. One role judged gameplay quality. One role detected unfair threats. One role planned combat pressure. One role turned game feel into QA automation. And one role guarded the release pipeline. But first, you need to see why these roles had to exist. The central game skill was the senior war game director. Its job was not to write code faster. Its job was to stop me from accepting weak work. Because in game development, passing tests is not enough. A missile can spawn and still feel unfair. A screenshot can look dramatic and still fail as gameplay. A system can compile and still be unreadable to the player. So the senior war game director kept asking one question. Can the player understand what is happening under pressure? That became the design gate. Not vibes, evidence, threat readability, weapon behavior, HUD placement, asset clarity, and performance feel. This is where AI agents became useful as more than coding assistants. The skill gave the AI a standard it could apply again and again across code, screenshots, telemetry, QA reports, and release notes. But the director needed eyes on the ground. That is why the next role was the threat detector. The threat detector looked for danger that felt unfair or unreadable. Were aircraft spawning behind the player? Was missile pressure arriving before the player had time to respond? Was the warning visible? Could the player understand the counterplay before taking damage? But the key idea is that the roles talk to each other. The director sets the standard, the threat detector finds the problem. The weapon planner shapes the solution. The QA system proves whether the fix worked. That is the workflow. Once the threat detector found problems, the weapon planner shaped the pressure. This is where the AI coding workflow became more like systems design. Missiles could not just appear because the game needed excitement. Aircraft needed believable ingress angles. Drone barrages needed cadence. The turret needed priority rules. Countermeasures needed a fair timing window. Damage needed to feel punishing, but not arbitrary. If this sounds like overkill for a solo developer, it is. Unless you have AI doing the heavy lifting. That is the point of this solo dev AI strategy. I was not asking AI to magically understand game design. I was giving it structured jobs inside the production loop. One role finds unfair threats. Another role plans pressure. Another role checks whether the player has a readable response. That is how the project moved from features exist to the game has intent. Then came the traffic threat detector. In Run the Strait, traffic is not just background scenery. Traffic creates skill moments. If the player threads awake, passes close without collision, holds speed, brakes late and escapes cleanly, the game should recognize that. So the AI helped connect those moments to scoring and HUD feedback. A good run should feel like the player is making precise decisions under pressure, not just waiting to be punished. Now this is where skill usage became concrete. The AI was not allowed to say, "Looks good." The first minute QA flow had to prove the first minute worked. Before you think this is only useful for complex games, this same logic works for a simple mobile app too. If an AI agent changes onboarding, payments, search or settings, you still need proof. Did the user reach the screen? Did the action complete? Did the edge case fail gracefully? Did the release build stay clean? That is why skills matter. A feature is something you add. A gate is something the product has to survive. The full root QA flow pushed this further. Run the Strait is built around a long survival route with open water gated after a 30-minute minimum run. So the AI QA automation system had to prove more than the game launches. It had to prove the route reached open sea. It had to prove the run lasted long enough. It had to prove the hull ended in a target pressure band. It had to prove intercepts, traffic pressure, skill feedback, and no unfair rear player targeted threats. That is the systems engineering side of autonomous AI game dev. You are not just asking AI to build the thing, you are asking it to help construct proof that the thing is real. Asset direction became another skill layer. Imported assets are seductive because they make a game look better very quickly. But visual richness is not the same as clarity. A missile effect can be cinematic and still hide the threat. A traffic ship can look impressive and still block the camera. A shoreline prop can accidentally read like a gameplay obstacle. So assets went through a simple gate. Keep, respin, remove. Every ship, missile, aircraft, water effect, smoke effect, shoreline prop, and finish marker had to support the player-facing fantasy. If an asset made the game harder to read, it was not an improvement. It was noise. This is where the senior AI director role mattered. It forced the AI to evaluate the game like a player would experience it, not just like a system that technically exists. Mobile controls needed their own planning layer too. On iPhone and iPad, the game maps touch and gyro into the same gameplay language as desktop. Then the QA automation could test the mobile layer directly. Skill defines the standard. Code implements it. QA proves it. But even with good controls and a strong design director, a game can still die at the finish line. That is why the final layer was the release guard where real launch pipelines live. For iOS, the release guard checked bundle ID, version, build number, App Store defines, privacy manifest, encryption settings, Unity services, analytics, ads, in-app purchases, game center flags, debug markers, and generated Xcode project state. That sounds boring, but boring is where shipping happens. A game can be playable and still not be shippable. So the AI workflow had to cover both sides of the project, the player-facing game and the platform-facing release constraints. That is the central idea of this video. Not one prompt, not one magical generation. This is my final launch checklist. 8 autonomous roles that moved the needle. A senior wargame director, a threat detector, a weapon planner, a traffic threat detector, an AI QA automation system, an asset director, a mobile control planner, a release guard. Together, they made AI feel less like a chatbot and more like a small production team I could argue with. I still had to decide the fantasy. I still had to look at screenshots and say, this smoke is too much, or this first missile is not readable, or this passes technically, but it does not feel right yet. AI gave me speed, but the skills gave that speed judgment, structure, and memory. And that is what made it possible to push Run the Strait from an AI-assisted prototype towards a launch-ready game. And if you want these specific skill templates for your own project, let me know in the comments. So if you are interested in practical AI-assisted engineering, agent swarms, and building real projects with these tools, subscribe and follow the journey.